Hello and welcome to a new video on IGCSE Physics Classified Paper 2. In this video, we shall be discussing the concept of efficiency. And efficiency basically means minimizing waste, minimum waste. So the more efficient an object is or a system is, the less waste it has. And how do you calculate efficiency? Useful output divided by total input. And since we like to express it as a percentage, so the result is multiplied by 100. These are the two main concepts that you need to know with regards to efficiency. Let's start solving questions. We will begin with conceptual questions. A machine is very efficient. What does this mean? It wastes very little energy. So the correct choice here would be choice C. It wastes very little energy. Two cars, P and Q, have different engines. The input power from the fuel is the same for both engines. The engine in car P is more efficient than the engine in car Q. Which statement about the cars or their engines must be true? So again, since P is more efficient, so P wastes less energy. It has nothing to do with using energy. P could be using much more energy than Q and still be more efficient because it's using a lot of energy, but it's also producing a huge amount of good output energy rather than wasted output energy. So the more efficient something is, the less energy it wastes. The keyword here is wastes. So D would be the correct choice here. Which expression gives the efficiency of a process? Like we said, it's useful output over total input times 100. So B would be the correct choice here. Useful energy output over total energy input. So B is the correct choice. Different processes have different efficiencies. Which row shows the most efficient process? So like we said, efficiency is calculated as useful energy output over total energy input. So if we do quick calculations here, this is 0.3, 3 divided by 10. 10 divided by 4 would be 0.25. 25 divided by 100 is again 0.25. 250 divided by 1000 would be 0.25 as well. So the highest efficiency here is A at 0.3 or 30%. If we multiply by 100, as we're supposed to, we get 30%. So A would be the most efficient process. Like we said, we divide useful output by total energy input. This is a division sign. So 0.3, A is the correct answer. The diagram represents the energy transfers for a device. The device is 50% efficient. Which equation is correct? Like we said, efficiency is useful output. So useful output over total input times 100. So this is equal to 50%. What does that tell me? That tells me that the useful output is basically half of the total input. So for example, if I have 100 joules of input energy here, I would get 50 as useful output and the remaining would be wasted. So 50 as well for the waste. Now let's look at the choices and see which one is correct. A says input energy equals useful output energy divided by 2. Of course, this is impossible because this means that the output is greater than the input, and this never happens because energy is not created. You cannot create energy. So A is definitely wrong. Useful output is equal to wasted output divided by 2. From the numbers we put in blue, we can see that the useful output and the wasted output are actually equal. So So again, B is incorrect. C, wasted output equals useful output. In this case, C is correct because each of them is half of the input energy. So they're equal to each other. You have 50% useful output and 50% wasted output. So they're equal to each other. And D also is wrong because it says that wasted output is useful output divided by 2, and we said that they are equal. So C is the correct choice here. The diagram shows the energy transferred in a lamp in 1 second. Which type of wasted energy is produced by the lamp? Does the lamp produce chemical energy or electrical energy or gravitational potential energy or thermal energy? Well, the lamp consumes electricity. So the input here would be electricity, electric energy in a sense. And the useful output would be light, and they already wrote that. And the wasted energy is heat in most scenarios and most cases. So thermal energy here would be the correct choice. D is the correct choice. A 150-watt filament lamp has an efficiency of 10%. 40-watt compact fluorescent lamp has an efficiency of 30%. Each lamp is switched on for the same amount of time. Which lamp produces more light and which lamp converts more energy into other forms of energy? So for the 150 filament lamp, it has an efficiency of 10%. So 10% means 10 over 100. So we're multiplying by 10 over 100 or 0.1. So the useful output here is 15 watts. How did I get that? I multiplied 150 by 10%. For the other lamp, the fluorescent lamp, CFL, the input energy is 40 watts and the efficiency is 30%. So 40 times 30 over 100. This gives us 12. So which one of them produces more light, more useful output? Of course, the filament lamp produces more light. So it's in terms of its output, it has 15 watts of useful output, and that's better than the CFL. So we know that A and B are wrong because the filament lamp produces more light. What about converts more energy into other forms? So converts more energy into other forms, this has to do with waste, basically, because you're using the input energy usefully, and then the rest goes to waste. For example, like we said in the previous question, it is converted into heat energy. So which of them wastes more energy in a sense? Of course, the less efficient one. So the one that has a 10% efficiency is wasting more energy than the other. So again, the filament lamp wastes more energy. So D would be the correct choice. So it is possible that the same device produces more useful energy and wastes more energy as well, simply because the input energy is much larger than the input energy for CFL. So D here would be the correct choice. Let's move on to calculation questions. So we have a diagram here with the input and the output, and we want to know the efficiency of the lamp. And like we said, efficiency is useful output over total input. So in this case, it would be 12 over 60. This isn't really a calculation question because you don't need to actually do the calculation. The correct choice here would just be choice A, 12 over 60 times 100. A solar panel is used to recharge a battery. The solar panel produces 0.8 watts of electric power. The panel is 20% efficient. What is the power input of the sunlight onto the solar panel? So efficiency equals useful output over total input. Now, the useful output is 0.8 watts. And we do not know the total input, that's what's required. So let's call this X. And the efficiency is 20%. So let's just write here 20 over 100. And then by cross multiplication, we can easily find X. So these two multiplied must equal these two multiplied. So 20X equals 0.8 multiplied by 100. So 20X is equal to 80. So X is equal to 4. And the input energy here would be 4 watts. So the correct choice here would be choice B, 4.0 watts. A lamp has a power input of 5. It wastes 1 watt of power heating the surroundings. What is the efficiency of the lamp? So as with previous diagrams, you have input energy, and then you have useful energy, and wasted energy. And of course, the total in must equal the total out. So the total input here would be 5, and the waste is 1. So we conclude that the useful energy must be 4. And efficiency is equal to useful output, which is 4, divided by total input, which is 5, times 100. And this gives us 80%. Therefore, the correct choice here would be choice C, 80%. Motor is used to lift a load of 40 newtons. The power of the motor is 40 watts, and the system is 20% efficient. How long does it take the motor to lift the load through 0.5 meters? So this is interesting. Again, we have a power input of 40. And there is useful power and wasted power. We're interested, of course, in the useful power. So how do I get the useful power? By using the equation. Useful out over total in times 100 gives me the efficiency. So the efficiency here would be 20. And we want to get the useful output, so that would be X. And the total input here is 40. So 20 equals X over 40 times 100. We can take the 100 to the other side. So 20 over 100 equals X over 40. And then we cross multiply. So 100X equals 20 times 40, which is 800. So X is equal to 8. What is X? X is the useful output. So this is the actual power that is used in the system. So we just figured out that the power here is equal to 8. How do I use that? So I should know that power is equal to work over time. And work is equal to force times distance over time. Again, so work is equal to force times distance, which means that power is equal to force times distance over time. We know that the power is 8. Excuse me. So 8 equals the force, which is 40 newtons, multiplied by the distance, which is 0.5, divided by the time, which I'm trying to figure out. So therefore, 8 equals 20 over time, and the time would be 20 over 8, which is 2.5 seconds. If you're wondering how I got the last equation, this is a mathematical trick. You can just substitute the 8 and the t, and the equation still works. If you don't really get that, you can do over 1 and cross multiply. So 8t equals 20. So again, t equals 20 over 8, which is 2.5 like we said. So the correct choice here would be choice B. this is the end of our video. Thank you for watching. I hope this was useful to you.